Tēnā koutou katoa, and very welcome everyone to you all. I am Mona Mokhtari, Principal Government Advisor in the commercial team at Manaki Whenua Land Care Research Group, and this is a real pleasure to be your facilitator today for our today's Link Online webinar hosted by the Bioeconomy Science Institute. Our today's session is Aotearoa 2055, Navigating Complexity for Making Good Land Use Decisions. I would like to introduce our presenters today. Dr. Melissa Robson-Williams. She is Group Portfolio Leader, Catalyzing Change. And our second speaker, Dr. Linda Lilburn, Principal Researcher and Research Priority Area Leader. Before I hand over to Melissa, I would like to go for a little bit of housekeeping. As you probably know from our previous webinars, this webinar is recorded and will be made available online in the coming days. The very important part is the Q&A function is enabled live on the top left. Please ask your questions only here, and we will aim to answer these questions at the end of the presentation. And also any unanswered ones will be answered later and emailed to you all. So I invite you to listen to Melissa. Handing over to you, Melissa.
Morena koutou. Thank you for the introduction, Mona, and thanks for organising this, Adrian. Welcome, everybody. We are really pleased to be here to tell you a little bit about this project that we call Aotearoa 2055. So as Mona said, I'm Melissa Robson-Williams, and I'm presenting here today with Linda Lilburn. We work at the newly formed Bioeconomy Science Institute and have been doing this project on navigating complexity with our BSI colleagues, Flo, Gwen, Clemence, and our colleague from Deliberate, Justin Connolly. So I'm going to tell you a little bit about the genesis of the project and then pass over to Linda to talk about what we've done. And then I'll finish off with the results or insights that we've generated so far. So it was a view like this that was the start of the project, really. Wondering whether our land use choices and configurations at a local, regional and national level are giving us the foundation for a resilient and prosperous bioeconomy into the future. When we think about land and land use change, currently we're often optimizing for only one or two objectives. But the question that nagged us as a research team working in complexity, as we all do, was what sort of aggregate choice would we make if we were considering the multiple and interacting complexities or challenges affecting land? If we were thinking about water quality, water quantity, biodiversity, biosecurity, fire, food security, soil quantity, soil quality, emerging contaminants, plastics, climate change, social well-being, economic well-being, and of course, underpinning all of that, energy. And it matters because when we optimize for just one or two things, we're likely to be causing problems and unintended consequences elsewhere. So we started to think about how we could support good local, regional, national decision making that was about land that was cognizant of all of these factors and their interactions into the future. We wanted to develop something useful that could help people consider this wide boundary view of land over time, and then start to identify insights as to where they might intervene or make changes. But here's the thing, that dealing with multiple and interacting complexities is head-bending stuff. Like, it's really hard to conceptualize, it's hard to think about, it's hard to do, and it's really hard to engage with. And we were sure that many of the types of insights that we were hoping to elicit were unlikely to arise from many of our normal analytical and communication methods, like numeric models, modeling outputs, reports, papers. So we knew we wanted to create something a bit more experiential, but in truth, at the start of the project, we weren't really sure what that was. So we convened an advisory group right at the start, and they gave us a really good direction. And the breakthrough came for this project when we came together to look at the causal loop systems diagram that Justin, our causal mapmaster, had been working on. Up until then, most of the rest of the team had been working on gathering technical information, material, and interviewing experts to feed Justin on different elements of that diagram. So we met and we saw this causal loop diagram for the first time, and then we decided to do something called an analog simulation. So this is where participants essentially inhabit and animate a system dynamics model themselves and play out scenarios over time, literally by moving marbles or later beans between cups on a map to demonstrate the dynamics of a system over time. And it was at this point that the project really took off. The insights that we got from just a few hours in analog simulation mode were really unexpected. And the interesting thing was that whereas for most other analog simulations that we'd heard about, they relied on participants having gained many of the insights about the system by having collaboratively built the diagram in the first place, we hadn't done that, and it was still effective. So we got really interested in the question of whether we could design an analog simulation process that increased visibility and understanding of the multiple challenges influencing land and their interactions, and start to help identify potential areas of focus or intervention without participants actually having to build the model in the first place, as this would massively expand its utility as a tool. So I'm going to pass over to Linda to tell you a little bit about what we ended up doing and what we ended up creating.
Thank you, Melissa. So the workshop activity, let's start with the diagram. We developed this causal loop diagram, which focuses on how we use the land. And we divvied up the land in New Zealand into 6 different land types, so the agricultural, plantation forestry, carbon forestry, biofuel, urban, and other, which was a big category. It had the dock estate, marginal land, retired land, abandoned land, and so on. And then within this diagram, we captured representations of energy, environmental quality, finance, population, consumption and the pollution that derives from that, biodiversity, food, fibre demand, prices and production, water allocation, carbon farming, mitigations and efficiency. The next slide is the diagram. Now, I don't expect you to read this, but just please admire its swirly beauty. It's the 3rd major iteration of our causal loop diagram. In addition, we've also done some more detailed diagrams in the background on some of the specific topics. For example, energy, biodiversity, and finance have got their own more specialised diagrams. So having pre-drawn the diagram, the challenge now is how can we make this accessible to a group who haven't seen it before, just like you haven't seen it until this moment. So we tried, first of all, an hour-long crash course in systems thinking at the start of the workshop. But the problem with this was it then meant less time for discussing the diagram and working through the decades. Feedback was the workshop could only be a day long at most. So we got around that by providing a 24-minute video of the training for homework for people to do beforehand. And in the end, each of the trial groups seemed to actually be able to engage with this diagram surprisingly well. The second challenge is the very high level of aggregation of the concepts and definitions. It's a lot to get on one page, even a big page like this one. What level of aggregation is appropriate? So for example, initially we had biodiversity just as a single node, but that didn't work. We needed to split it. First of all, we tried a native versus exotic split, and in the end we settled for good biodiversity and the bad biodiversity, like the pests and things that we don't want, and that worked better. The scale that we're working with is national scale, which of course in itself is a very high level of aggregation as well. So the workshop, one-day workshop, as I've said, 7 to 9 participants plus the team. We gave a brief introduction to some system thinking concepts. Each of the participants was assigned some cups or topics that they are the arbiter or the moderator for. Beans in a cup are either increased or decreased depending on the changes in stock. So if debt or water quality or oil price goes up, more beans are added. A scenario is defined at the beginning. So this sets the political and the societal mindset that is in place for the activity, and also the climate change projection. The facilitator guides the flow of the discussion, and the participants discuss those interactions and agree how many beans to add or remove. And then we repeat that for 3 to 4 decades. The first decade, from 2015 to 2025, so in the past, was done as a demo by the team, and then we would turn it over to the participants and the facilitator for the following decades. We needed a logic to be able to work through the diagram that supported the discussion about the interactions. So this is the logic. We'd start with the context and the demands. So we'd think about the macro context. What are the demand for the products? We then move on to the choices in the land use. So what are the activities we'll put the effort into? What are the costs? How will we use the land? And then finally, bringing that together with the consequences. What are the environmental impacts? What does this produce? And what are the benefits and costs do we experience? And we do that in 10-year increments. So just giving more detail, we'll go around the diagram following that logic. So in this logic, we started with the macro context, the political mindset, the climate change projection. So that includes, for example, how many flood and drought events are expected in the coming decade. At the bottom left, Melissa's going to indicate, I hope, with the population change, domestic and international, oil and carbon prices, and therefore the demand for liquid fuel and alternatives for energy. We discussed the viability of shipping, which is a reinforcing loop with available oil. We need shipping to bring the oil to New Zealand, but bringing the oil to New Zealand needs the shipping to be viable. So it's a loop. And thence to domestic and international demand for food, wood products, wool products, forest products, including the tension with food imports and food security. The final piece of the context, over on the other side of the diagram, is the amount of fresh water, which of course is impacted by climate change. Moving on to choices in the brown colour, the first is how to use that fresh water. How much are we going to retain for ecological, recreational, cultural reasons? How much for urban and industry? And then how much for irrigation? The next choices are made as to how much to focus on agricultural efficiency investments, how this was paid for, how about mitigation practices, the benefits of which might not be seen until the next decade, hence those boxes, which are the delay boxes. We discussed Jevon's paradox, whereby efficiencies may in fact lead to greater use of a resource, not less. Next was the levels of inputs used in the farm systems, operational costs for the agriculture sector, and the final choice in that hexagon is how we use the land. What conversions do we need to do in this decade, moving from one land type to another that might be needed to support the decisions that are being made? And the third part of the logic in green being the consequences. This started with the pest species, including wilding pines, the pollution of the environment through consumer goods, microplastics, PFAS, chemicals. Then we discussed water quality, soil quantity and quality, and functional biodiversity. Bringing this all together here in the middle is where we assessed our capacity to grow food and fibre, and therefore how much we might be able to grow given the areas of each land type, how much we would then grow in the flows there. This then leads us to the financial implication of changes in our revenue and the profit, debt, insurability, and finally we finished with the societal well-being right up there at the top right. And then we repeat it all again for the next decade. So to date, we have had 2 within team workshops and 3 external workshops. Our advisory group, who were a mix of regional council people and future farmers. And then we did a group of young farmers. And then the third one was some senior researchers from the Bioeconomy Science Institute. Each time we've refined that process a little bit more. And so far, it's only been national scale. We have had interest in regional and catchment. It probably needs a redrawing of the diagram. And then the next slide is just showing you a picture of our internal workshop testing the activity. Melissa's now going to summarise what we learned from the workshops.
Thanks, Linda. So, in order to assess this evolving analog simulation process, we collected reflections during and after each of those workshops Linda mentioned, and also interviewed all of the participants. And we basically got 3 main insights. So the first one was that it was really effective at broadening perspectives. So a recurring theme was that participants learned about areas that they didn't know much about or hadn't thought about previously. It made people aware of critical dependencies and factors affecting their area of focus or research or work that they hadn't considered before. So novel insights for participants included the reliance on access to cheap energy, especially liquid fuel of our primary sectors, and the risks that poses into the future. The magnitude of the impact of pests, potential impact of fire, emerging and novel contaminants, the whole financial bit, which was a tricky area for a lot of people, and the knock-on impacts of urbanization and sea level rise on food and fiber production and the tensions there. And the learning was especially effective where the participants had expertise in their cups. So it was quite a practical way of building connections between people and also between different areas of knowledge. The second thing was that the experience was really important. So all participants reported gaining a deeper understanding of the system that we'd mapped, and they attributed this to what they called experiencing the system and its interactions. And it was this experience that made the activity much more impactful, for example, than seeing model outputs or reading a report. And participants said that they experienced the system through owning or holding a cup or cups, physically moving the beans around the diagram, having discussions with colleagues, having to think about what might happen and all of the dependencies, and then seeing where beans accumulated or depleted. They also gained an appreciation of consequences through experiencing delays. So multiple times people had an aha moment when the benefits of an action took time to accrue and they were experiencing frustration or disappointment that it hadn't been started earlier, and therefore gained insight on the timeliness of some interventions. And in particular, this experience was really useful in identifying intervention areas. As we progressed through the decades, inevitably parts of the current system as mapped would start to break down, or the costs and consequences were deemed just too high. And this sense of tension that participants experienced, that we just wouldn't or just couldn't keep doing XYZ, was really informative for prompting reflection on possible areas of future intervention. And the strength of the activity is that it can be run with different mindsets, as Linda said, and different scenarios. So it actually allows people to explore and experience plausible consequences of different futures. The third insight was kind of ongoing usefulness. So most participants saw a useful application for the activity at different scales or for different audiences. So we heard a lot of, oh, these people would really benefit from doing this. But we were particularly interested to understand if the usefulness of the activity for the participants was just on the day or whether it stuck with people. So in the weeks following the workshops, more than half of the participants reported that they had already used something that they had learned from the activity, and often this involved drawing on the diagram, pulling it out in order to broaden considerations when thinking or discussing an issue. What was missing? So feedback in the earlier rounds, one of the really important missing area was social consequences in the system. In the latest round, which we just did last Thursday, we had a discussion at the end of each decade about societal well-being, which actually seemed to work quite well as this kind of useful integrated discussion at the end of the round. What all of the impacts, all of the things, the choices and the consequences, what that would mean for societal well-being. Another important limitation is that we haven't reflected Te Māori. So we deliberately didn't try and capture multiple worldviews on a single causal diagram, partly because it's very, very challenging to do, but mainly because you end up doing a bit of a disservice to everyone. But as we've said in our other systems work, we think that taking this wider boundary systems view can really benefit cross-knowledge system work. And in terms of the final limitation, in some ways, a strength of the process is also a limitation. So the fact is that different groups will navigate through the activity differently. They will get different things out of it. The system structure, i.e. the diagram, does have some authority. So the system structure does signal system behavior, but the process is animated by the participants with all of the strengths and limitations and biases that we all carry. So given the insights, the thing that it seems to do well, and the limitations, we think that it's probably most useful as a kind of an opening up discussion tool for navigating complexities around land at a macro level, for helping take a wide boundary look at land and identifying potential areas of focus or intervention, and for kind of integration and cross-learning. So in terms of what next, to be honest, we are at a bit of a crossroads. We have a few potential pathways that we could pursue. We've tested it with some councils, we've tested it with some primary sector folks, we've tested it with some scientists just last week. So actually, to help us figure out where our next steps are, we wanted to take the opportunity to ask this audience about whether there are any applications or challenges or groups that you think this activity could be useful for. So if there are, please reach out and catch up with us. We would really appreciate that. But I'll wrap up there, and we are, super happy to take any questions. Thank you for your time.
Great. Thank you very much, Melissa and Linda. We've got a lot of questions and also a lot of thank yous, claps and praises already coming through. I'm going to start from the very first questions saying, are you able to share the systems thinking homework or concepts used with this workshop? This is from Sam Stephens.
As in the 24-minute one? Is that what Sam meant? I certainly think we are.
They say, yeah, systems thinking homework or concepts used.
Yeah, that's a great idea. We hadn't thought about that. That's a great idea.
Yeah, perfect. Cool. The next one I've got is, do you only consider financial viability but not economic viability? This is from Soulful.
As in the kind of macroeconomic viability? Maybe you have to unpack that question a little bit more for me.
Yeah, okay. If they can just put a bit of more info under that one, we can get back to the question. Another one from Paul is, what weighting was given to the elements? If there was any, I mean.
So loaded within the system structure, they weren't. It wasn't weighted. But what happens with any kind of system structure, with a system diagram, depending on, for example, the scenario that you're running or the circumstances, that certain loops will have more power than others. So that's what it essentially gives you your system behavior. So your structure stay the same, but your system behavior will change. So depending on the scenarios that we were running, the political mindset, certain loops, certain feedback loops would have more power than others. But this was part of the discussion between the participants. So we didn't load it into the system structure. We let people essentially explore that. That's a great question.
Cool, thank you. The next one from Borwell, remind us what the beans represent.
Good question. So, Linda, do you want, because I'm just hogging this, do you want to answer this one?
The beans vary depending on what the cup is. So within the land areas, they actually represented they were different tokens, but they represented a percentage of land. But the beans in the water sources for fresh water, for example, it was a nominal amount that we had that represented all of the water in New Zealand, fresh water in New Zealand. So every bucket had a number that didn't represent a particular value or a particular unit. That was just an amount that was appropriate for that particular topic, that allowed us to play over the decades and see it go up and down.
Oh, that makes sense.
Conceptually, there's stocks in the system, so that's what the beans were representing. It was a stock, different types of stocks, as Linda has articulated.
Cool, perfect. The interesting one from Andrea is, could you take this model a step further and develop it into a computer game type experience where when you manipulate some aspects, the others respond, and this then visualize the consequences? Very interesting.
Yeah, it's a good question, and we have toyed with, we have certainly discussed it. I suppose one of the things that we were interested in is literally the tactile experience of people participating. So it's an analog simulation for a reason. It's not a computer simulation. So what we heard from people, that literally the physical experience of having to kind of count beans out, move beans around, it actually helped with that understanding. So it obviously is more limited. Your idea of making a kind of a computer simulation would widen the kind of the potential impact, but there was certainly something about that, the experience of it, that was important.
Oh, perfect. Next one from interesting. In this analog model, how did you apply or assess time delays?
Yeah. So there are delays. I mean, you saw the causal loop diagram that Linda showed up. I mean, there's a lot on there, and there are delays all over the place. But we chose just 3 places where we would deliberately represent delays. And the way that we did this was that if you had, for example, if you put in a bunch of mitigation practices, then you could load that, you could increase the stock of that in a cup, but it wouldn't be until the next decade that you would see the benefit of a percentage of those going into the soil quality or the water quality. So we literally had beans on those little clock icons in order to signal where significant delays in the system are.
Perfect. I think I'm going to get one more, and then we have to wrap up. The next one from Jessica. How is this being used by government agencies? Is it being used by government agencies in decision making, or are you sharing this as a potential learning opportunities for government agencies to learn from?
It's a really good question, and we were really kind of why we were keen to come and do this link seminar, is to get to expose it to a wider group of people to see where it might be applicable. So not yet, but if people think that there is kind of benefit and interest, then they're super happy to do that.
Cool, perfect. Thank you very much, Melissa. I can see loads of more questions, lots of thank yous and praises, and great comments. But we just are on 10:30 and we need to wrap up here. I would like to thank you for the fantastic presentation, and also I would say we had a great number of attendees, great number of questions, and we will answer these questions and we will share with you in a very upcoming week. And so I would like to say the recording also load onto the YouTube, so please keep an eye on the website as well for that. Thank you again for your time and engagement, and also looking forward to seeing you in the next webinar. You guys have a great rest of your day. Thank you.